All right, so what we're going to do is we're going to take a look at basics of a series circuit. So hopefully I get this right and we can make sure everything works right. So as we said before, I have two videos on series circuits. Basically, a series circuit is just plainly, you see that? No, you can't see that. Let's do this. Let me hold on. So we got basically is a series circuit. And if you look at a series circuit, you got a couple resistors we call loads. I'm just going to put a few loads in and I'll label them. R1, let's say it's 100 ohms. R2 is 330 ohms. And R3 is 470 ohms. And we have a 10-volt battery, positive and negative. That is the basic circuit right there. That's what we call a basic circuit right there. So we look at the basic circuit. We know that current in conventional flow, because we'll call this conventional flow, will flow from the positive to the negative. And I talked about why current is the same throughout the circuit. But just to rehash that, we take that as an amp meter and we put an amp meter over here. So we had 2 amp meters. Let's throw another amp meter over here. So there's some amp meters in there. We know that the amp meters will display the current. So the amp meter displays the current, and we know that current, and we measure that in amps. And other abbreviations we basically use in these circuits in milli, which is 10 to the minus 3. So it would be milliamps, so we do give it a designator as MA. So in looking at the circuit, we know that this is a series circuit based on the fact that current flows through one resistor, picks back up a speed, and then it flows through another resistor, picks up another speed. So we know that this circuit is a series because each one of these resistors is tied to each other. So A, let's call this B. So this is going to be B, can't be C, B, C, and then D. And if I'm looking at these points, this is the C point right here. So we can look at it and say that current flows from A through R1, so it's going to slow down. Once it hits B, it's going to pick up back speed. And then from B, it's going to flow through this resistor, R2, and it's going to pick up speed again. And then it'll go through R3, and then it's going to pick up speed again, and it's going to finish itself off. So we can say that the resistors R1, R2, and R3 are going to limit the amount of voltage, as well as it's going to cause some sort of current to flow too. So when we look at how much voltage we drop on R1, R2, and R3, we call those voltage drops. So we call VR1, VR2, and VR3 voltage drops. So we know that the larger resistor will drop the most voltage. Likewise, the smallest resistor will drop the least voltage. So this one's going to drop about 1.1333 volts. And then this is going to be 3 times as high as that. So this is going to be 3 times 3 is almost about, I'm going to give it about 4.2 volts. And this one's going to be about 6.9 volts. So it's 4 times as high as that. So it's rough estimation, but you see that if the larger resistor will always drop the most. So when you're looking at a circuit like this, you just want to pay attention to see what you're doing. We can also say that in a series circuit that R total is equal to R1 plus R2 plus R3, which again, this proves series because it's additive. It's additive. So if you have any questions about this type of circuit, again, email me. But if we're going to if we're going to go deeper into this, we know that we have to talk about power, and we'll get into that later on. But each one of these resistors is going to drop a certain amount of voltage, but also because of the IR relationship, which is called the voltage drop, we're going to actually create some current there too. So we can say that the 100 ohm, the 330 ohm, and the 470 ohm is going to drop so much power. So again, when we look at the circuit, we have to decide what size resistors we want, and the size of the resistor in watts, whether it's 1 watt, half watt, quarter watt, whatever, is sized up correctly. So most of our circuits in the lab will be between a quarter watt to about 1 watt power. So if you have any questions, please feel free to contact me.